So we are going to continue working with our determinants. We have basically managed to work with the basics, which is necessary actually for us to solve simultaneous equations, which is the major case that we are going to look into, solving simultaneous equations. And from the determinants concept, and that is referred to as the Cramer's rule, which is used to solve simultaneous equations. So we know that simultaneous equations, we can have two unknowns. All right, we can have two unknowns, we can have three unknowns, according to your syllabus. So we are going to consider in this class two unknowns from the Cramer's rule, how to apply the Cramer's rule to solve for those two unknowns. Remember, when given a simultaneous equation, we have got two equations with two unknown values. For two unknowns, you'll be given two equations with what? Two unknowns. That is the concept. So let's say we have an equation 3x. All right, let's just have 3x is equal to 17 plus y like this. Another one, minus 11 is equal to minus x plus 3y. Then these are simultaneous equations with what? Two unknowns. The most important thing is that when solving simultaneous equations, depending with the method that you are to use, the order is very, very important. When I say the order, I'm referring to the standard form of how these equations must be presented. The standard form, a way of presenting our simultaneous equations. So the standard form is given in the form, all right, so we're going to just use constants A, B, C. So we're going to have A1x plus B1y is equal to C1. Then I'm going to use A2 plus B2y is equal to C2. So A1, A2, these are coefficients of x. B1, B2 coefficients of what? Of y. Then we've got C1 and C2 as the constants. So, in order for us to solve for x, solve for y, depending with the method that we are referring to, the Cramer's rule, it states that to determine or to find x, we are going to use the formula dx over d naught, delta x delta naught. That is determinant with respect to x. Then this one is for constants. So this is with respect to x. This is for constants where we've got a 0. And y is equal to delta y over what? Delta 0 for the constants. So it is what you are to determine x, determinant with respect to x for that x. It is y that you need, so determinant for y. So the question is, when I say delta x or dx, you can write as dx the way that you understand, or delta x. What is it exactly that we are referring to? Delta x is representing the determinant for x. But this determinant here, when we put x here, it means replace x, the part of x, the coefficients of x, replace them with constants. Replace the part of x with constants. Our equations are here. This is the part of x. X, x. Right? This is the part where we have got x. So in actual sense, you are supposed to take what is representing x here, which is a1 and a2, the coefficients. But we are saying we are going to replace that part of x with constants. And these are the constants c1 and c2. Remember, these are the constants. So delta x, you close the part of x, you replace with what? Constants, c1 and c2. c1, c2 in that order. All right? So the part of y is not affected because we are dealing with what? With x. So you just replace the coefficients of y as they are. The first part, the coefficient of y is what? b1. The coefficient of y here is what? b2. You replace with those coefficients. So this is the determinant that you must determine with respect to x. The part of x is replaced with constants. So this was the part of x. You replaced with constants. The part of y is not affected. You just replace the coefficients of y in that order or in the manner that you're having from your equations. So this is the case. The part of x is no longer x. It is now represented with constants. So I'm simply saying dx replace x with what? With constants. The part of x, you replace it with what? Constants. So if I'm referring to delta y, the determinant with respect to y, it means I'm going to replace y with constants. So x is not affected. X is not affected. We are referring to y. So x is going to remain as it is, meaning to say this time the part of x is not affected. All right? We are focusing on what? On y. So the part of x is not affected. You just take your coefficients as they are. What is the coefficient of x here? It is a1. What is the coefficient of x in the second equation? It is a2. All right? So it is the part of y which is affected because we are going to replace it with constants. Just like for x, you replace with constants. So this part of y, since we are referring to y, we get rid of it, then replace with constants c1, c2. That is the case. So we're going to have c1, c2 in the part of y. Just like that. Just like that. Replace y with constants this time. So x is not affected. It is y that is being affected. What about delta naught, which is for the constants? As we refer our delta naught or delta zero, delta naught, with respect to the constants this time, it means the constants are ignored. We are to ignore the constants. We are to ignore them. So if we are to ignore the constants, I want you to see that if this part is being ignored, are you seeing that we are having already what we need on the left hand side. A1, A2, B1, B2. They're those coefficients making up a determinant. So meaning to say this one, we're just going to ignore the constants, then take those coefficients in that order. So for X, it's A1 and A2. This is for X and this is for Y. So A1, A2 as it is. For Y, their coefficients B1 and B2. B1, B2. So take note, I have a plus here. So that's why I'm not focusing about the signs to say this is minus what. So if there's a minus, you must consider the sign that is affecting the coefficient of Y. The coefficient of X, you take with the sign. If there is a negative, you take with a negative. The coefficient. Just like that. So here you have to determine what? Determinant. You simplify it, you evaluate. Then after that, you are simply going to substitute those into the formula. For Y, for the constants, then you can determine the values of X and Y. Just like that. Just like that. So what you need is the standard form first, rearranging, having that standard form. Then determine your determinants. Substitute into the formula, you're done. All right. So these are some of the steps that we can just consider as we are revising. Follow this procedure to solve simultaneous equations for what? Two unknowns using the Cramer's rule. Step number 1, rearrange the equations into standard form. So that is the format that I presented there, your standard form first, with X and Y lined up vertically and constants on the right hand side. All right, that is our standard form. We know that one. So that is, you must have the standard form first. Then number 2, find the determinant of the coefficients, which is our delta naught. We saw the formula. Ignore the constants on the right hand, set up two determinants. All right, so that is, they simply need us to find these determinants. All right, find the determinant of X. You do the same thing, the determinant for Y, any order that you want if you are using that. All right, so you must have those determinants. Then apply what? The Cramer's rule. So the Cramer's rule is the formula that we have here. So that is, they're saying you must apply that at the end in order for you to find the exact values of what? X and Y, just like that. So you see, guys, it's just something that is straightforward. Once you have the standard form, then determine what? These determinants for of the coefficients of X and of what? Of Y. Then you apply your Cramer's rule. So I'm going to use this as an example. So after that, guys, just do as many questions as you can. We are going to look into exam, but I'm just going to put this example so that we use that. It is just a basic thing that you just need to follow up. Just make sure you consider the signs properly, all right, where there's a negative, this and that. So I'm going to use this as an example. Let us use this one as our example. Let's say we are being asked to solve simultaneously for X and Y. Solve for what? For X and Y. How are you going to solve for X and Y? Using what? Cramer's rule. Using the Cramer's rule, the first thing that we need is the standard form, how to present these given simultaneous equations. As we are seeing here, we must have the part of X and Y on the left-hand side, then constants on one side of our equation, which is the right-hand side. So let us see what we can do. As we can see, let us rearrange. We did the standard form. So here 3x is already on the left hand side. We can just ignore it, just take as it is. 3x, all right? Y is on the right-hand side, so I need to bring this to the left-hand side. So take note, we start with x followed by what? Followed by y. So if we take this y to the left-hand side, it's going to be a negative there. So that's minus y, which is equal to 17. All right? The second equation, it is up to you. You could have just taken this, it will be positive x. You take this, it will be minus 3y as you transpose. But another aspect here is that we can see that already we have x and y on one side of the equation and the constant on the other side of the equation. It's only that the sides are not the way that we are supposed. We are supposed to have this on the what? Left hand side and this on the right hand side. So just transpose them. Remember, if A is equal to B, it means B is equal to A. So just take as it is, the whole part here, just bring it what? To the left hand side. As it is, it's just like swapping these two to say, okay, this is equal to this. So there is no change of sign. Minus x plus 3y is equal to what? Negative 11. I can just do this way. It is fine even if you had to take this and becomes positive x. This one becomes negative 3y, and you take this to the other side, it becomes a positive 11. It is fine. You're still going to obtain same answers. Do not worry about that. You just arrange the way that you understand. Here I just took advantage to say already x and y are on one side of the equation. The constant is also on the other side of the equation. So it's just rewriting to their corresponding sides. Just like that. So these are the two equations that we have, equation 1 and equation 2, where we have x and y as our unknowns. So using the Cramer's rule, in order for us to solve for x and y, we are supposed to use this formula. And this formula is limited because we must have the determinant for x, determinant of y, and determinant of what? The coefficients. That is the constants, I mean. The determinant of what? Of the constants, as we had before. So this is what they are saying. Work out those what? Determinants separately. Work out that separately. Work out those separately. Then use the formula at the end. All right, so it is up to you which one are you going to start with for x, for y, then for the constants that you have. Delta x. Replace x with constants. The power of x you replace with constants. So this is what we are going to have. All right, let me just put it here. Okay, it's only that our equations are this side. Let me do this. I just want you guys to see exactly where I'm writing also so that you can follow up. But anyways, you think you can understand from what I'm going to explain. Don't worry. So this is it. Let us have our dx, delta x. So this is it. Where we have x, I said you must what? Cover up that. Replace with constants. Where we have x, we are going to replace with constants. So our constants in this case is what? All right, 17 minus 11. So in place of x, we are going to have 17 minus 11. The part of x is replaced with constants. But we saw that y is not affected at that moment. We are just going to take the coefficients of y as they are b1 and b2. So this is the same thing. It is x that was affected, but y is not affected. We're just going to take y as it is, the coefficients. This is the part of y. So we need the coefficient This is 1 with a negative. So you're talking about what? Minus 1, the coefficient of y. What is the coefficient, the number that is multiplying y? Minus 1. That is your coefficient with a sign. So you have got negative 1. The second one, the coefficient of y. What is affecting y here is what? Positive 3. Positive 3. So this is your delta x. You need to determine the determinant of that. Just like that. You do the same thing for y, you do the same thing for the coefficients, all right? So delta x, all right, let us quickly find this, guys. Remember from our previous class, a, b, c, d, the determinant is equal to AD minus what? Minus BC, product of the major minus the product of the minor diagonal. So you're just going to have 17 and what? 17 and 3. 17 times 3 minus the product of this minor diagonal, minus 1 and minus 11. Minus 1 times minus 11. So this is you and your calculator. You can simplify each separately. That was going to be 51 minus negative is going to be positive. So delta x is going to be equal to 40. Just like that. So you have got your delta x. Just like that. Direct is just determinant, guys, that you're finding here. All right, so let me just have it here. That was equal to 40. The same for y, you do the same thing. For y, you're going to close the part of y this time is the one that is affected. So x is not affected. You're going to just take the part of x as it is. X is not affected. So you're going to just take your x as it is. Y is the one that we affect. So x, the coefficients, the part of x. So the first one is what? Is 3. Positive 3. This is minus x. What is the coefficient? Minus 1. The number that is multiplying x will be negative 1 coefficient. Then y is the one that is what? Affected. We are going to replace this, the part of y, with constants. And that's 17 and what? 17. Okay, let me just put another color here. 17, negative 11. So this is the effect now. X is not affected. Y is the one that has to be affected. You place it with what? With those constants. Then determine what? Determinant. Remember your determinant as we had before. The product of major diagonal 3 and what? Negative 11 minus the product of the minor diagonal 17 and negative 1. So that's it. So you're going to determine this negative 33, negative, yes, negative 17. Then using your calculator, you're going to obtain negative 16. All right, so this is determinant with respect to y, negative 16. All right, let us have the one for of the coefficients, delta naught. So our delta naught, the coefficients is going to be equal to, remember this time, we are closing the constants. So you're just going to use the coefficients as they are on the left-hand side. All right, A1, B1, A2, B2 as it is on the left-hand side. X and Y as it is on the left-hand side. So in our case, what is it that we have? The coefficients, just going to take X and Y as it is. So X, 3 and what? Negative 1. Then Y, there is what? Minus 1 and positive 3. Minus 1 and positive 3. The constants are not included. They are not to be replaced anyway. So this is your delta naught. All right, find the determinant just like before. 3 and 3 in the major diagonal. 3 times 3 minus what? Minus 1 and minus 1 in the minor diagonal. So that's our delta naught. 3, 3, that is 9, minus 1, which was going to give us what? Which was going to give us 8. So that is how we can simply find this. So that was going to give us 8. And using the formula, now we can determine the values of x and y, because we said x will be equal to delta x over delta naught. So that's x will be equal to delta x, 40. And our delta naught we calculated, that was what? That was 8. So it's going to be 40 over 8. Therefore, x will be equal to 40 divided by 8. That is what? 5. Just like that. And y will be equal to delta y over what? Delta naught. So that's why delta y is negative 16. Our delta naught is 8. So that's y is equal to negative 2. So these are the values, that is the value of x and the value of y that we are going to obtain, which you can prove by substituting into the given equations. So you can prove that the left-hand side is truly equal to the right-hand side. Just like that. So it will be just finding of determinants, guys. Do not even worry about this. Just make sure you have the standard form. Determine your determinants. After that, use your Cramer's rule, just like that. So we are going to have more questions coming up, exams. Make sure that you join the membership so that you do not miss any of the other classes that we are going to have on our mathematics N4.